我们有请来自谷歌的资深工程师 Jason Wang 和 Mitch 为大家带来的联合主题分享：单体已经死了，单体万岁！让我们有请 Jason Wang 和 Mitch Okay, the last topic for the first session is the monolith is dead. Long live the monolith. By Mitch and Jason Wang from Google. Welcome.
Hi, and greetings from beautiful Seattle, Washington. My name is Mitch Connors. I'm a software engineer at Google, and as you can see, I enjoy being in the woods.
Hi, everyone. My name is Jason Wang. I also work for Google and also on the East Hill team, and also live in Seattle, Washington.
So we're here today to talk to you about monoliths, which might strike you as a little bit odd, right? This is KubeCon, Kubernetes Con, the Cloud Native Compute Foundation's annual conference, where we're supposed to talk about containers and microservices, not about monoliths. Well, we're not in the wrong place, and I want to make sure that you know neither are you. You see, microservices are a brand new technology. If you look at the rate of adoption, they're an awesome, cool technology to have conferences about, but a lot of people are still going to be in this long hump of adoption. Looking at the curve, it says about 80%, I might even say more than that, of users still are going to own one or more monolithic applications. And so we want to have a story for them about cloud native technologies that doesn't simply involve abandoning all the work that they've invested in their monolith and carving it up into microservices. You shouldn't have to refactor your entire code base to take advantage of cloud native compute. Additionally, we're talking about monoliths because at Istio, we actually migrated our architecture to monolith. We had microservices up until our first release in 2020, about March. We went ahead and migrated those 3 microservices into one comprehensive monolith. And you know what we found? It was actually a lot easier for our users to deploy and manage, and it was a lot easier for us to troubleshoot. So even if you're not on the long tail here, you might have made the choice proactively to use a monolithic piece of software. And we want to show you how you can take advantage of cloud native technologies without moving to microservices. So let's start by defining monolith. Oxford English Dictionary tells us it's a large single upright block of stone. That definition works maybe as a metaphor, but I think Wikipedia gets it a little bit closer to what you and I are talking about. A monolithic application is self-contained and independent from other computing applications. It comes from the Greek single rock, and I got the usage chart here, which I thought was interesting. Nobody seems too surprised, I think, about this early 2000s crest of talking about monoliths. Everyone was talking about moving to service-oriented architecture and microservices. This bump was a little bit more interesting. I'm curious to know why everyone was talking about monoliths in the 1870s. I don't think it was about the Babbage machine, but if anybody knows, please hit me up on Twitter. I'd love to hear the answer to that. Well, so when we take into consideration that definition, independent from other computing applications, I think you'll find that true monolithic applications are rare, right? All of our applications have dependencies on other applications. At the very least, even if you've got a combined front-end, back-end server, you've probably got a database for persisting data. You're probably not doing that yourself in process, even if it sits on the same computer. Still not quite a monolith. You've got some networking traffic there that might have latency you're interested in, might need security. Additionally, you don't tend to get your users sitting at the same computer your monolith is running on, right? You tend to have users who are on the internet, and those users are coming to you via a load balancer or a gateway or a firewall. So true monoliths are pretty rare. Most of the time what we're talking about is really a macro service. It's one process that just has lots of functionality packed into it. You've got business logic, you've got front-end logic, you've got logic that maybe nobody really knows what it does anymore, but it's still there and everyone's afraid to take it away. We want to talk about, for people like that, how do you own a monolith, bringing it towards cloud native compute technologies without going through all the pain of a refactor. So I want to introduce you to Our Pet Monolith. We're going to be talking about a company called the Hipster Shop. Hipster Shop is an online boutique. You might recognize it as an example from Google Cloud. Usually Hipster Shop, we're talking about microservices, but what we've done for the sake of this talk is we have recomposed those microservices into a single container running as a monolith. Now, the one way that this monolith might be slightly different than the monolith that you run is that it is still communicating with itself over TCP. Requests from the product page to the reviews page to the ratings page are happening over TCP, and that is actually a change that we would advocate for making inside of a monolith. It's not a complete refactor, but it does involve some elbow grease. But the cool thing is, with just that little bit of elbow grease, I think we'll be able to show that there are a lot of advantages that you'll be able to find with cloud native technologies in your monolith. Feel free to follow along with us. Since we're all sitting at our laptops anyways for this demo, you can check out all the code we're running on GitHub there at the link. You can also use our monolithic container at the Istio testing hipster monolith repository. So feel free to toy with or play with this yourself. Also, a lot of our examples that we're going to run through, we had to sort of abbreviate them so that they fit on the screen, and we really don't expect you to write them down from the screen. So go ahead and check out GitHub, where we'll have detailed examples for you to follow along with. All right, so let's see what the first challenge we want to do with our monolith is. The CEO of Hipster Shop comes to his dev team and says, guys, the website is just way too slow. I've been waiting for it to load forever. I'm worried that customers are going to give up and we're going to lose money. I need you to speed things up. Why is it running slow? And what changed? It was growing great last week. Well, as a dev team, we know that the Hipster telemetry system is not really a system. It's more like 7 systems. There's a log scraper, and the part that the intern rewrote last summer did use a telemetry system that was hooked up to a dashboard, but nobody really knows how that part works. Identifying exactly where this latency comes from might be difficult. We could run it in debug mode and get trace dumps of absolutely everything on the application, but that's going to slow it down even further. I wonder if we have another option. So we could refactor our monolith to add in consistent telemetry and tracing across the code base, or we could use a service mesh. Jason, tell us what we can do.
Sure. Yeah, before we actually look at example and integrate it with a service mesh, let's look at Istio. Istio is a service mesh which is developed by Google and IBM and a few other organizations. In the Istio mesh, you can see in the diagram, Istio D lives inside the control plane. And the control plane is where we actually do the configurations for most of our Istio APIs. So Istio D is responsible for reading and pushing configurations, discovering proxies in the mesh, and configuring certificates for the proxies. On the data plane, the proxy that we're talking about are basically Envoy proxies, which are very popular these years. And a lot of organizations are starting to adopt Envoy proxies. So the proxies are injected alongside with each workload, and they are the main entry points for the traffic in and out of the workloads. As you can see in this diagram, the diagram is created to help understand microservice architecture, but no worries at all. Istio will also work for monolithic applications. And let's see an example. Next slide. All right. So as we mentioned, we want to leverage service mesh, which in our example is Istio, to help with our monolithic applications and look at telemetry. So in this example, we are integrating our Hipster shop, which is running on VM, and leveraging a Kubernetes cluster. In a Kubernetes cluster, it is created to just host Istio D, Prometheus, and Kiali. Istio D, as we mentioned, is installed to push configurations to the Istio proxies or Istio proxy on the VM. And Prometheus and Kiali are installed to scrape metrics and display service telemetry graph for us. So as before, external traffic is directed to the VM that includes the Hipster shop monolith. And in our case, we need to configure workload entry in Istio so that VM is actually treated in Istio as a normal Kubernetes workload during proxy configuration. And the VM is also included as part of the mesh and known to the other proxies. And so with that being configured, we can easily get some initial graphs and telemetry using Kiali and Prometheus. And you can see that we have some request count, request size, telemetry being ingested by just integrating Eastio into our application. And we can already the traffic flow from the external to inside of our hipster shop application without extra configuration. And also in addition, we can configure Jaeger to provide tracing data for us within the mesh.
All right, so we've been able to get telemetry data for our monolith. We've been able to identify where the cause of our latency was and go ahead and patch that to keep our CEO happy without touching a single line of code. But as is true in business, change is constant, especially in this industry. So the next day, the CEO is back with the dev team to tell us awesome news about this acquisition of the company called Reviewly. Now, Reviewly is an awesome startup. They're all about doing great high-quality reviews from users and getting them sourced well. And so we want to go ahead and integrate that with the hipster shop. And the CEO has asked us to start using the Reviewly API for our reviews instead of our existing one as soon as possible. Well, as a dev team, we're a little bit less excited about this. We know that Reviewly runs on Kubernetes. They're already containerized. And because they're already containerized, they've been able to take advantage of a weekly release cadence, just constantly shipping with continuous integration, continuous delivery products. On the other hand, with our VM-based monolith, we have a quarterly release cadence. And the reason for that is so that after 2 months of development, we can do a 1-month bake test. There's a lot of moving parts and no one understands all of the code entirely. We want to make sure that we haven't broken anything when we roll out a new version of Hipster. And so we make sure to let it settle in, make sure that we understand how its performance is going to work before we push it out to customers. We're not exactly sure how we're going to test a new release of Reviewly every week. So we've got two options. We can refactor the monolith, finding everywhere that we've used the reviews API and replace it with the Reviewly API. That's probably not too difficult. It's probably maintained in a config file. We can get over that. But we also are going to need to ask Reviewly, all of these new developers who are excited about their acquisition, we're going to have to give them the bad news that they need to move to waterfall, right? They need to start quarterly or maybe monthly release cadence so that we can keep up with them and they're not breaking things for us. Or there is another option. We could take a look at using a service mesh. Jason, tell us how a service mesh can help us solve this problem.
Sure, let's add Reviewly to our service mesh. Now let's see, given our already configured Eastio service mesh, we already have the VM which is running the hipster shop and it's already in our mesh. And now we're adding Reviewly as another service in the service mesh. Note that we're putting only one Kubernetes cluster in this example, but we can also configure another Kubernetes cluster which may already be running Reviewly and put it also integrated in our current service mesh. So to do that, we simply add a virtual service in Eastio. Virtual service in Eastio is an API that allows you to configure traffic routing among services. And you can see in the example here that we are redirecting all the reviews traffic from the hipster shop to Reviewly service that we just added. Using the same external service address, external users or other consumers are able to just see the new results from Reviewly just by accessing the same endpoint for the product page or hipster shop.
But Jason, it looks to me like what you're talking about is a point-in-time cutover from using hipster reviews to Reviewly reviews. I mean, is that safe? What happens if Reviewly causes problems? Is there any way to have some certainty about this?
Yeah, exactly. I think a lot of people have been trying this kind of practice before by doing canary deployment, where in canary deployment, you can try to migrate your traffic from one or the other and test out if one version is working or not versus the other one. So in this example, we just introduced the Reviewly version 2, where we can do a canary deployment for V1 and V2, and also by using virtual service. And in the example here, you can see that we're giving each one of the versions with equal weight of 50, and they combined, added up to 100. So meaning that now we have, on average, 50% of chance having the reviews traffic go into reviewing version 1 and 50% chance of going to reviewly version 2. So you can, in that way, you can test out a new version before it actually rolls out. All right, so now we have two services and two versions of the service. Now we wanted to bring it to production. And before we do bring it to production, we definitely want to do some additional testing. And you may hear the term chaos engineering in the past. And one of the practice in chaos engineering is to actually do fault injection. So in this example, we would like to inject some fault to our Reviewly V1 service to make sure it is running still fine with introduction of V2 version. And in the code snippet here, you can see that we are introducing a fixed delay of 7 seconds to the service, to the V1 service. So we can actually test out in our mirror traffic from production. And notice that we're testing this out in a staging VM, which we replicated from our production VM. And it should be running the same traffic and same request, the same as the production environment.
All right, so we've survived 2 crises with our CEO. We've made no changes to our monolithic code base, but now we've got observability for both Reviewly and for our legacy application. We've integrated it, and we've made sure that there was no downtime. Even when there were bugs in our integration with Reviewly, we were able to detect them early, roll back quickly, and get them patched, as well as some really interesting testing and staging. Now our next challenge, right? As soon as the CEO leaves happy, our CISO, Chief Information Security Officer, walks into the office and he says, guys, I just got back from this awesome conference. Everyone there was talking about the cool new thing called Zero Trust. So I've gone ahead on Twitter and I've announced to all of our customers that we're rolling out Zero Trust by the end of the month. Make it happen, team. Well, the dev team might be a little bit less excited than our CISO about Zero Trust, because we know the Zero Trust means that every request is going to fail by default unless it's explicitly been authorized in some sort of a whitelist system. And we don't have a whitelist system. We also know that we're going to have to authenticate not just the server, as in normal HTTPS, but also the client side of the request. This is all done for a really good reason. It means that there's no security perimeter. Whether an attacker is coming from outside of the data center or from within your firewall, there's no way for them to compromise many services in a zero trust environment simultaneously. So it's a great plan, or a great idea, but man, how are we going to implement a plan like this? Well, we've got 2 options. We can refactor our monolith and refactor Reviewly to use mTLS auth for every single network call. Our monolith, I think we said, was in Python, and so the request module probably supports mutual auth somewhere if we figure out the configuration parameters. Reviewly was written in JavaScript, so we might need to find a JavaScript library that supports mTLS, and then we got to make sure that we configure them to be compatible with one another, which might be a little bit tricky. We might be looking at several months. We might need to push back on our CISO's timeline. Or we could use a service mesh with Spiffe. Jason, tell us how that's going to work.
Yeah, exactly. I think when talking about security, normally we're talking about 2 aspects. One is authentication, which is talking about who is making the call, or kind of identity of the caller or the callee. And as well as what can the caller do, which is authorization in that sense. So let's look at authentication for the first case, where we can enable mTLS, as Mitch mentioned, for the service mesh. So mTLS is a two-way communication, two-way authentication that both the client server authenticate each other at a request. So this helps that no unknown services are able to communicate with the services in our mesh. You still can enforce that entire service mesh to be mTLS compatible by using peer authentication API from eStill. And in this configuration, you can see that we're making mTLS in mode strict, so that all the services in our service mesh are compliant with mTLS and are able to are being encrypted. And in addition, about who can make the call, and to further enforce this security, we can also add policies that only allow certain workloads to perform certain operations on a service. So when we are doing this, we are giving each service a specific identity that is unique within the mesh. And in this example, we're only allowing the hipster shop identified by this identity cluster.local /namespace/default service account hipster shop to perform a get operation on the Reviewly service. Please note that this is helpful in production environment, especially when, for example, hipster shop get compromised by a hacker or someone else, and the individual is actually not able to do any write operations to Reviewly in that case. So it actually further protects our Reviewly service without being further compromised in a cascading way. Yeah, so that's how you can configure security for your service mesh.
Nice. All right, well, let's review real quickly where we've come. We've shown how modernizing your monolith is easy with an Istio service mesh. We've done this with security, Envoy and Spiffe. We tested in production, including using fault injection and canary deployments. We showed you how you can migrate traffic from your VM into your hybrid cloud environment with multi-cluster Kubernetes. We also looked at observability with Prometheus, and now if you want to, and if you have a business need to, you're ready to start using the strangler pattern to carve off sections of your monolith and migrate them into Kubernetes as needed. And we've done all of this without touching a line of code. So I hope that you can see from these examples how you can take the things that we've shown today and apply them to your monolith and bring some of the cloud native compute magic back to your monolithic code base. We've got some helpful links for you to check out. We're also available on Twitter on the schedule. So hit us up. And now we're ready for any questions.
我叫范康。
好，非常感谢我们两位嘉宾的精彩演讲啊 ！Thank you very much. Thanks Jason. Thanks Mitch for a wonderful speech. Now it's our QA session. 好，现在呢是我们的问答环节。为了方便我们的演讲嘉宾回答大家的问题呢，建议大家尽可能的用英文提问，在这个问答框中呢，大家尽可能输入英文。我们的演讲嘉宾已经上线了，稍后呢就对大家的问题进行回答。
So I see a question about bootstrapping config. It asks if we're in transition to Istio and we are already generating some Envoy configuration, can we use that configuration moving forward alongside Istio? And the answer is that this is not a supported operation. Istio would not help you troubleshoot this. However, Istio does expose bootstrap config to Envoy, and that is configurable if you dig fairly deep into the Istio installation parameters within the mesh config. You should find bootstrap. And I will try to answer with a particular URI to the documentation for that section. So it wouldn't be a supported operation, but it should be possible. Thanks for the question.
“大家还有问题吗？我们的问答时间还有，希望大家能珍惜这个机会。Okay, let's wait for another few minutes for our attendees to generate more questions for you.
Sounds great.
Is Jason there? Can he?
Yep,
speak?
I just joined.
Jason, can you speak Chinese?
Yeah, 我能说中文。
啊，太好了，我想是不是英文回答可能会让我们的观众有一些难度。好，大家呢现在如果有中文有一些问题可以用中文提问啊，因为 Jason 可以用中文回答。
We have a new question.
我看到有 Yeah, we have another question. Yeah, Mitch, feel free to answer another question.
Sure. The question is how we see the future of service mesh interface, and will Istio fully meet the requirements of SMI? So service mesh interface is a project that's come about as a collaboration from our friends at solo.io. I think they're probably presenting a few talks at this conference as well. They're usually around. And what they sought to do is abstract out away service mesh implementations like Istio, Linkerd, etc., so that you could write one config and have it apply to all of them. I think it's a really interesting idea. I don't think it's quite borne the fruit that I would have hoped to see just yet. So I think it's a technology that is developing. I'm excited to see what they come up with over the coming year. As far as will Istio fully meet the requirements of SMI, as far as I am aware, Istio's functionality is a superset of what SMI exposes. So some of Istio functionality can be driven through SMI, and some of it cannot. And that's because SMI can only expose functionality that is available in all service meshes. So in areas where Istio distinguishes itself as unique, SMI struggles to, at least in my understanding, and again, I am no expert on that. You should talk to Christian Posta or Edith Levine if they're around about the details there, and I'm sure they'd be able to give a much different perspective on that.
我们的观众朋友如果只能用中文提问问题的话，也是可以的啊，因为 Jason 在线可以用中文回答大家的问题。
Yeah, I think there are another two questions. Mitch, are you able to answer any one of those, or I can go ahead and answer
Yeah,
those?
so I can tackle the first question here about the difference between Istio's provided Envoy version and the official Docker image for Envoy. If we were to use the official Docker images in Istio, what would happen is we're on a quarterly release cadence, and I believe Envoy is also on something like a quarterly release cadence. So that would mean that when Envoy is working on a feature and ships it, it would likely be another quarter beyond that before Istio is able to take advantage of it. And we at Istio are very interested in exposing the bleeding edge of Envoy functionality and performance to our users. So what we tend to do is around the time we're cutting a release, we will take the previous release of Envoy and cherry pick all of the best features from the upcoming version that are still stable into it. And that is what we release. So you can sort of consider, in some ways, the Istio bundled Envoy to be something like a preview release of what will be shipped by Envoy onto Docker within a few months.
Yeah, regarding the second question, it's a good idea to access Mongo or Redis via Istio. I think Mitch and I were talking about this question actually a little earlier. We do have examples of Mongo and Redis, and we actually we support those protocol inside Istio. Personally, I haven't tried it using Mongo or Redis on Istio, but I'd love to try it out afterwards, and also feel free to raise any issues if those don't work for you in community. I think we have a bunch of people have experience in that.
We do, and actually with regards to Redis in particular, the hipster shop that you just saw the demo built on top of uses Redis. And it was built particularly as an Istio demo. in the microservices, and then we packaged it into a monolith for this, but it's still using Redis within the monolith. So you were able to see traffic flowing to and from Redis with telemetry, security, and all of that, and it worked fairly well. If you've run into problems about a year ago accessing databases with the Istio sidecar, there were some difficulties with protocol detection and protocol sniffing. There have been a lot of improvements over the last 12 months in that area. So if you had a little bit of trouble a year ago, give it another shot. Kick the tires. And if you're still running into trouble, we are always hanging out at slack.istio.io or discuss.istio.io. And I would definitely be interested in hearing about any problems that you're experiencing.
好，那我们今天的问答环节就暂时的告一段落了。好的，我们非常感谢大家的积极互动，让我们再次感谢 Jason 和 Mitch 的精彩分享和对我们问题的详细解答。